I've had this pillar drill for, well, I don't know, 10 or 15 years, and one thing it's lacking is variable speed control. I can change the speeds of it, but that's all manual. And perhaps the lazy option now is to get a speed controller with a rev counter. So that's a project for this morning, and here we go. Yeah, right, okay. Banggood. I buy a lot of electrical stuff from Banggood. Pretty good if you don't mind waiting 2-3 weeks for it to turn up. £8 for the rev counter with a proximity switch. It's a magnetic proximity switch, but they give you a magnet, so not all's lost. I've got a variable speed controller for the motor on the pillar drill. Bit suspicious, £8. I have taken it a bit, so I'm going to give it a go. Bit worried, there's a lot of metal on here and no earth connection, so that's probably going to be in a second video. But today I'm going to concentrate on getting the rev counter fitted, just so I know how fast my drill is actually going. Thinking of mounting it in this plastic box, another Banggood special, just to keep the dust out of it. So I think the first thing is mark that box up and make some holes. I've marked out where I want to have the cutout for the display. I usually use masking tape because that doesn't mark anything you're trying to cut, and if you make the odd mistake like I do, you can just simply peel it off, put another bit of masking tape on. What I found good in the past to cut plastic boxes is mains powered Dremel with a little cutting disc in it. You can do very straight lines with that rather than doing it freehand. It works for me, so we're going to give that a go now. Just keep your fingers clear of the blade or the cutting disc. And the other thing I always do, safety wise, is cover the mug of tea with a cap, because the last thing you want is bits of grit and plastic floating in your tea. So we'll give this a go. You can see how I get on. That seemed quite good. Cut a nice line just where I want it, on the inside of the line, so I can always file the plastic out to suit the display. I'd preset the Dremel height for the cut I want to make, so as the display is going to go central into the enclosure, I'm just going to flip that over, cut another line again, and reset for the two ends. Right, fourth cut, here we go. Right, not bad. Couldn't go right to the very ends there, because I don't want to damage the plastic that you may see. So I'll get one of my blunt knives. I kind of figure we're not that far shy of cutting this out. Hopefully I won't split the box into two. Well, this is another Banggood special. I pay £2, have them delivered, and you get half a dozen boxes turning up after 3 weeks of placing the order. Not the end of the world, but you don't really want to do things twice. A little bit of cleaning up we need to do here. perhaps a little bit more clear up. Let's just give it a rough. Yeah, it's not bad. I'll get those corners cut out and we'll have a look, see how well it fits. Right, there we go. Managed to find a sharp knife. What I find gets better results is not necessarily a file, but if you've got a sharp blade, you drag it along like that, you fetch a lot of material out and it still remains fairly square. File's okay, but it's a bit more localised. We'll try that for a fit. Get those bits out the way. Going to take a little bit more out for the clips that hold the display in. I'm tempted to cut those off because it's quite a snug fit anyhow. So we'll perhaps try that and see what it looks like with the tape removed. You see the tape I put on earlier. Well, we can take that off. You don't leave any marks on the box. It's not quite as straight as I'd like there. What's not helped is there's internal pillars which were more difficult to trim off. Yeah, I think we'll lose those side clips on this. Go and get a pair of side cutters, remove those, and we'll fit it in the box, see what it looks like. That's the side clips gone to a better home. Let's just see what the fit's like now. Yeah, that's fine, that'll do for a garage. Let's see if we can get the proximity sensor mounted on the drill and see if we can get something powered up in a few minutes. I thought I'd just show you the proximity sensor before I install it into the pillar drill. There's at least two sensor types that I'm aware of. One is it changes state when it comes into near contact with metal. This one isn't that type. This is a magnetic proximity sensor. So you can see on the end of the knife there's a little magnet. Once that becomes quite close to the sensor will change state, hence it's detected the magnet. If we whiz that a few times past the front of the sensor, it thinks it's on a rotating shaft, and you get the display. So my plan is to install a magnet on the fan blade of the motor on the pillar drill, and attach the proximity sensor into the housing that protects you from slicing your fingers off on the fan. So that's what I'm going to do now. I'm just going to mount the magnet onto the fan. Because it's such a low mass, it's not going to off center or cause the fan to be out of balance. If it was any bigger than that, I'd be a bit concerned, but that weighs nothing. That's not going to have an effect. So I'm going to glue that on and mount a hole in the bottom of the fan casing, which I'll show you once I've done it. Here's the magnet the sensor is going to detect. I'm just wiping it over with isopropyl alcohol to remove any grease. I'm going to use double-sided sticky tape to mount it onto the fan blade. Now this particular brand of double-sided sticky tape is excellent. You pop it on like that and it's resistant to many things. Water, it will not come off with water. In fact, if you do want to try to remove it, isopropyl alcohol and a lot of time will do it. But yeah, it's going to be fine for this purpose. There's no mass to the magnet, so it's not going to whiz off and take a window out. One thing I'd like to show you, we've got to remove the backing from the double-sided sticky tape to expose both sides. What I found to be good, you just fold it back onto itself like that, push it down. Then it's relatively easy just to remove the backing paper and away you go. It's off. You try to do it any other way and it is difficult to detach the backing paper. That's the way I found anyway. So I'm going to stick this onto the fan blade and drill a hole in the fan housing and see how we get on from there. I'll come back to you. That's a proximity sensor mounted in the fan cover of the pillar drill. So we'll just move that over to the drill now and position that sensor correctly, the right distance from the magnet without bashing onto the fan blades, and we'll see if it works when we turn the pillar drill on. Refitted the fan housing cover. You can see the proximity sensor hanging out the bottom of it. If I just tweak the drill spindle by hand, you'll be able to see the LED just blip. Not very clear, but to me it is flashing on and off just as I'm swinging the spindle. The fan blades aren't hitting the proximity sensor, which is a bonus. So we'll fire the drill up and see if it actually detects the revolutions. Yeah, the display's flashing on the camera, but to me that's perfectly steady in real life. So we'll press the go button and have a look at the display. I'll switch the pillar drill off, and there you go, back on once more. Get a bit of a spurious reading at the end. I guess that's where it's reading the magnet twice as the motor's slowing down, vibrating. But certainly when it's running, we get a steady reading. And that's what I'm looking for. So we've got to mount this on the drill somewhere where I can see the display, and I'm figuring we're looking somewhere there. So I'll go make a bracket and get that mounted. At the moment I've got the display powered up by an external 24 volt power supply, which isn't what I'm going to have permanently. But what I'm going to do, a few months ago I added an air nozzle to blow the swarf away when I was drilling, and I powered that up obviously through an air line, but also the solenoid valve for the air control is on the 24 volt power supply, so I'm simply going to take a tap in from that power supply to feed the display. One side effect of that is the power supply only powers on when the drill's on, so it'll take a split second for the display to become live, but that shouldn't be a problem. This is a plastic cover off the 24 volt power supply I was telling you about earlier. I'm going to use that cover and the readout like that. I'm going to knock a couple of holes through the cover, screw that into the side of the display housing, and we're going to mount that on the side of the pillar drill. And I think that's probably not going to look too bad. We'll knock a few holes through and see what it looks like. Right, that should be fine. I will put that together and mount it up on the drill. I've got to get the cable from the proximity sensor into the case here. So rather than just drill a hole in the case, I'm going to fit a cable gland. So let's see what size hole. Just under 12 mil. what I've learned off videos on YouTube, rather than starting off with, say, a 4mm drill, working up to the 12mm size you need, and going through about 6 drills in the meanwhile, these step drills really good. You drill a pilot hole still, well, I do anyhow, just so I can make sure we're bang on where we're drilling, then just slowly step up one by one until you got the desired size. So I'm gonna try not lose a finger here, and we'll go up to the 12mm, which is the biggest one on this step drill. They do go a lot larger. That goes up to 32mm, and there's even bigger ones in the cupboard. But really good, it's time saver, and the drills don't rattle around. Well, this doesn't rattle around like drills do. So here we go, 12mm later. Just need to go slow and steady. This step drill's been used on steel, so it's not quite so sharp as I'd like it to be. There we go, nothing broken there. And the cable gland will pop in nicely, and we can run the cable in nice and neatly to the box. Okay, well, we'll put a bit more of this back together and you can take a look in a few minutes. That's mostly the wiring all back together there. I've got 2 cables coming out. That's to mount up to the 24-volt power supply that operates the air duster. So I'll get the old soldering iron out, make those 2 connections good, screw together. We should have a working unit. There's the finished rev counter or tachometer, whatever you wish to call it, mounted on the drill press. It's in my eye line to some degree, so I can read it when it's on. So it'll only power up when the drill is on, because the 24-volt power supply is derived from the air duster that I have on the machine. So we'll switch it on, see what happens. Yeah, that all works. The burst of air at the end you heard was the air valve just switching off. That's when it loses the mains to the 24-volt power supply. I have put the inductive sensor actually on the motor itself, so regardless of how I change the gearing on the pillar drill, which I can do, there's about 6 different settings to give you different spindle revs. The plan is to put a variable control on the motor, electronic controller that will govern the speed of the motor. So hence the rev counter reading that you get in will vary depending on the motor speed, and of course that'll have an effect on the spindle speed. This is how I used to change the gear settings. You change the 2 pulleys, 3 pulleys that are sitting in there with 2 different drive belts. The plan is, as I say, is to fit an electronic speed controller to the motor. That's where the proximity sensor is mounted on the motor spindle. So at the moment the spindle speed will be different to the motor speed, but I plan to put a 1-to-1 pulley on there, so you get a direct readout on the rev counter of the actual spindle speed, the chuck speed, and that's obviously what I'm looking for. I'll add a link in the description to all the parts I've used on this project. If you're interested in getting any of the stuff that I've used, it's all fairly cheap, as I say, from Banggood, majority of it. If you don't mind waiting the 3 weeks, then it's fairly good quality. I hope you enjoyed the video. Leave any comments you wish and look out for part 2. Well, I tried the speed controller and unfortunately it's not really suitable for the motor I have on the pillar drill. So what I'm going to have to do is stick with the old multi-change belts and speed control, the old manual speed control I should say. Lift the lid, move the belts, change the revs. But obviously with that in mind, where the proximity sensor is mounted is actually on the base of the motor, and that's taking up the true revs of the motor, which I'm not really interested in now. Is the spindle speed. So as I'm going manual, I'm going to move the proximity sensor to that position, which will line up with this pulley, which I will now stick a magnet onto the outer rim. That'll pop back on there, and that gives us direct speed readout of the spindle, which is ultimately what I was aiming for. So yeah, I'm going to dismantle the old proximity sensor, move it, do a job twice like I normally do, and I'll come back when I've got that all installed. Pull it all back together with the magnet that worked before, but it wouldn't have any of it, not this time. I can only assume when I mounted it on the fan blades, I mounted it at an angle like that, and maybe the magnetic flux is stronger that way as far as the proximity sensor is concerned. Anyhow, I found an old hard disk, and I've dragged the magnet out from that, and that's what I'm going to use now. Just putting some double-sided tape on it. Sometimes use double-sided tape, so double thickness tape. There you go, and I'll just put it on the outer rim of the pulley there. I did trial fit this earlier and it did work, but I want to stick it down with a bit of tape as well. I don't really want that magnet flying off when the machine's working. Hopefully this will be more successful. One hopes so. Just trim that off and we'll get that back into the drill press. Yeah, these magnets are neodymium, if I pronounce that right, very strong. But yeah, that's what I'm planning on using. And it does work when you run it around manually, so I'll put that back together and we'll fire it up and see what happens. Well, that's the pillar drill all back together now, with the display on the side and the proximity sensor remounted just under the cover of the drill. I'm still going to have to contend with changing the speeds manually. As I say, the speed controller wasn't up to the challenge, so not a biggie. Yeah, it'll be okay. But the main thing now, rather than having a look in here what speed the drill thinks it's going, there is an actual speed readout, and we'll give it a go. That's what I'm looking for. Works a treat. If you have any more ideas of things I can make, break, fix, etc., feel free to leave comments at the end.